All right, so next up here, we're dealing with solving proportions, setting up unit rates, and scale drawings. So I want to start off here with something that is really applicable to your everyday life here, and that's unit rates. Okay, you probably don't hear that word a whole lot, but you see it a lot if you go to the grocery store. So I have a couple boxes of Cinnamon Toast Crunch here. In my opinion, one of the better cereals out there. All right, and I pulled this off of Wegmans.com. And if you go to any grocery store, though, this is already on, where the price is. Obviously, like the price is the biggest number you see, like on the tags at the grocery store. But if you look at the labels, they do tell you the unit rate. Okay, and when we're talking about cereal here, it's in the price per ounce. So you'll see right here on this first box. This is like the smallest box of Cinnamon Toast Crunch you can get. It's only 12 ounces. They say it's 27 cents per ounce. And what they're doing there is they're taking the cost, so $3.19, and they're dividing that by the 12 ounces. All right, and when you do that, it does come out to 0.2658. They obviously round it up. We're dealing with money here. We only go to the hundreds place. So we round this up to 27 cents per ounce. Okay. And then, as you would think, as you move your way up here, the 19.3 ounce box, is $4.19, and that costs 22 cents per ounce. So it's 5 cents cheaper per ounce there. But again, they're doing the same thing, $4.19. Divided by the 19.3 ounces. So again, there's probably some rounding involved here. $4.19 divided by 19.3 comes out to 0.217. But again, we just round this to 22 cents per ounce. All right, and then the cheapest one, of course, is the big family size one. It's the big box. It's got 2 bags in it. It's way cheaper, 14 cents per ounce. So if you remember back, that small box was 27 cents per ounce. So this is almost half the price per ounce. But again, we're doing $6.19 divided by 43.75. And it comes out to 14 cents per ounce. Again, there's some rounding there, but roughly 14 cents per ounce there. All right, so unit rates, you see them all the time. You drive past any gas station. That's an example of a unit rate. Right now gas is like $2.50 or so per gallon. That's a unit rate. The cost per gallon of gasoline. Okay, but gas stations, grocery stores are filled with these unit rates. Anytime you go in the produce section, the deli section, everything for sale there is based on the price per pound usually. Okay. So going back to my gas example here, I said I purchased 24 gallons of gas, and it cost me $61.44. So if we take our $61.44, divide that by 24 gallons. And the big thing I'm looking for here is not just the math, because the math isn't too bad. We just got to do 61.44 divided by 24, and we get 2.56, is the labeling. Okay, so this is $2.56 per gallon. Okay, so make sure you're putting the label there. That's really what I'm most concerned about here. Other unit rate, miles per hour. So if you don't drive yet, and you see all those signs along the road for the speed limit, that's another example of a unit rate. You see 35, that's 35 miles per hour. That's how many miles you would travel in 1 hour. Again, our denominator is 0 with these unit rate, or denominator is 1, denominator is 1 with these unit rates. So we're doing 138 miles in 2.5 hours. So that's 55.2 miles per hour. Pretty good speed there. Not too slow, not too fast. All right, but that's your unit rate. Unit rate is always something divided by 1. Okay, denominator. Okay, so you're always going to have that denominator of 1. Make that arrow a little bit better. You're always going to have the denominator 1. Again, when you go to the grocery store, all those rates are for 1 pound or 1 ounce. Gas stations, that's your price for 1 gallon of gas. So denominator is 1. So next up, we got to start working on solving proportions. All right, and these aren't too bad. All we're going to do is cross multiply. So we're going to cross multiply and solve. That's really it. So we're going to do 3 times 8 equals 1 times x. So that means 3 times 8 is 24 is equal to x. Not 22, so x equals 24. Moving on then, again, cross multiply. So 5 times x equals 2 times 3, which is 6. So x is going to equal 6/5. That's it. Nothing else. Cross multiply and solve them. So same thing here. We're going to do negative 1 times 2x equals 5 times 3. So negative 2x equals 15. So x equals 15 divided by negative 2 equals negative 7.5. Some of these you're going to have to do a little bit more work to solve. So we're going to have 3 times 21. It's going to be equal to 14 times x minus 2. Put that in parentheses. We're going to have to distribute that 14. So we're going to have 63 equals 14x minus 28. So now we got to solve this equation. We're going to add 28 to both sides. So it's going to be 71, 91 equals 14x. So that means x is going to equal 91 divided by 14, which is going to be 13 halves. You can reduce it down to 13 halves or 6 1/2. Either of those answers will do. Whoops, let me move down there. All right, so I reduced my 91 14ths down to 13 halves. Both are divisible by 7. And you can either leave it as 13 halves or 6 1/2. It doesn't matter to me. So again, moving on here with solving some more proportions. Cross multiply is your first step. So 3 times x minus 2 equals 4 times 7. So that's going to give me 3x minus 6 equals 28. So 3x equals 34. So x is going to equal 34 thirds or 11 1/3. Again, cross multiply here, so 3 times 20 equals 10 times x plus 7. So that means we're going to have 60 equals 10x plus 70. Now you're going to solve this. Subtract 70 from both sides. So negative 10 equals 10x. So x equals negative 10 tenths. So negative 1 for a final answer then. All right, two more of these again. Again, your first thing, you just got to cross multiply. So we're going to have 3 times the x plus 4. Don't forget to distribute. 7 times x then. So that we're going to end up with 3x plus 12 equals 7x. This is the equation we have to solve then. I would subtract 3x. So we get 12 equals 4x. And then x equals 12 fourths, or just 3. All right, so again, cross multiply, then you're right back to solving equations that we were doing a couple weeks ago. A lot of them are just two-step equations. But just don't forget to do the whole cross multiplying thing. You always be aware of what you're multiplying by. And last up, this is the first one we had where I have 2 binomials for you. So we're going to do 4 times x plus 3. 3 times x plus 12. And by the way, it doesn't matter what order you go here. If I had 3 times the x plus 12 here and the 4 times x plus 3 here, doesn't matter. It's all good. So we should get 4x plus 12 equals 3x plus 36. Solve that equation now. Subtract 3x from the left, subtract 3x from the right. So we get x plus 12 equals 36. Subtract 12 from both sides, and we should get x equals 24. All right, and last up, we just have some scale drawing stuff. And the main thing here is just keep your proportions organized, okay? The hardest part here is getting your proportions set up correctly. Once you get that done, you'll see it's really not too bad. But definitely getting it set up, you got to be careful. So it says a model of a building is built to a scale of 1 to 65.5. One side of the model is 23 inches long. How long in feet is the side of the actual building? Okay, so first up, we're told that it's 1 to 65.5. So in the numerator, I put the model. In the denominator is the actual. So that's the scale. If the model is actually 23 inches long, all right, so in the numerator goes my model, so that's all in inches. In the denominator, that's all my the actual building itself. So to solve this, not too bad. We're just going to cross multiply. 23 times 65.5 equals 1 times x. So that's really it. I got to do 23. All right, and one thing to think about with these, it came out to 1,506.5 feet, is that we got that the model was 23 inches long. How long in feet is the side of the actual building? If it's 1 to 65, we go the other way around here, and we did 65 divided by 23. You get 2.7 something maybe. You wouldn't tell me that the actual height of a building is 2.7 feet. It wouldn't make any sense of a building that only has one of the sides is 2.7 feet tall. It just doesn't make any sense. So always think about your answer in the end. Make sure your answer makes sense, okay? Last up, we got a map here. A map of Indiana is made to a scale of ½ an inch is equivalent to 20 miles. So I'm going to go 0.5 inches is equivalent to 20 miles. So map is in the numerator. The actual is in the denominator. Indianapolis is 128 miles from Fort Wayne, so we're trying to figure out how much it is on the map. So we got x inches divided by 128 miles. So cross multiply here. We have 0.5 times 128 equals 20x. So that's going to be 64 equals 20x. 64 divided by 20. So x equals 3.2 inches. I'm okay with decimals here. All right, but again, make sure your answer comes out a lot smaller here. You know, if you messed up like one of your fractions, you'd end up with doing 20 times 128, which would be, and then divide, which is 2,560. Then you'd have to divide it by 0.5. You get 5,120 inches. I don't know how many feet that is, but it's a lot of feet. And you're talking about this is how big it would, how far they'd be apart on a map. You know, so if you did figure that out in feet, it'd be 426 feet. No map that I know of is 426 feet long. So always try and think about your answer in the end. You know, does it make sense?